اوكي خلاص في الساين الاحمر ده صح؟
Yes.
Okay. Good morning, good afternoon everyone. Today inshallah we will continue on our topic of triple and multiple integration in general. In this lecture we will handle the topic of making triple integration. It's very, very simple and it's similar to what we did in the previous two sessions. The triple integration extends the concept of single and double integration to 3-dimension, and it is a concept in multi-variable calculus. Triple integration are used to integrate functions of 3 variables, so I'm expecting to see up to 3 variables, x, y, and z, over a 3-dimensional region, D, as we will see in the coming slides. They are commonly used in physics, engineering, and they have plenty of applications, evaluation of a volume, of a mass, of a center of gravity, and a lot of applications actually. The triple integration will be like this. This is we are integrating around a volume of a certain function. So you will have 3 integration signs. The first of them, as we know, exactly in the double integration, it can go through it can start with dz, dx, dy, same concept, almost the same concept, or changing to be dx, dy, dz. We will decide based on the simplicity of the service that we want to integrate on. If you remember in line integration or in the normal integration, we usually integrate on a single or on a simple domain in one direction. And so if you are integrating with respect to x, you will integrate from x equal to 1 up to 5 or something like this. If we are dealing with double integration, we will have 2 stacks or 2 integration signs, and we will do dx, dy, dy, dx. Mainly if this is 1, we will be evaluating area. But for triple integration, if we don't have any functions here, we will be evaluating a volume of a function. Of course, the coordinate systems that can be worked with surfaces, as we studied at the beginning of our course, start to memorize what we did and what we took in our course. We can deal with Cartesian coordinates, cylindrical and spherical coordinates. And the change of variables between these systems, it will depend on the simplicity and the type of the service that we are going to deal with. As I told you, we can do a change in order of integration. So either integrating dz, dy, dx, or if you like to have dx, dy, dz, and the other alternatives. Of course, this is also applied or applicable due to the Fabian's theorem of the triple integration version. So if I have x, y, and z, a continuous function on a rectangular box, for example, if the domain is a, b, c, d times e and f, and if I want to do an integration for an evaluation of a volume through this region, it's gonna be simply like this. The volume is gonna be, this is the triple sign of integration, and these crosses will start with that for dx, that part for the integration limits of dy, and that's for dz. So if you want to integrate, I will do dx, then dy, then dz, and in order, this is gonna run from a up to b, determining the volume that you are integrating with. This is from c to d, and the last one from whatever. This is gonna be from from e to from E up to F. So you can integrate also exactly the last time. We will integrate first with respect to x, considering everything else is a constant. Then we will make the substitutions from A and B, and so on with respect to dy and the dz, as we will see in the coming slides. So, as I told you once more, this is going to be the function, and we will integrate with respect to dz, dy, dx, or vice versa. Remark that if we change the order of integration, if we change it, the order of integration, also the integration limits will be changing. So here, if I started with dx, you will go to from a to b, then from c to d, and then finally for dz from e to f. If I started with dz, because you are dealing with a cube, you will start from ef first, then cd, then finally from a to b. So all the integration limits will be the same, and almost everything. That's the generalization of the Fabian method according to our main slides, which states exactly the same as we spoke earlier. This is for dx, dy, dz. If you like to do it dz, dy, dx, or dz, dx, dy, or you have 6 iterated integrals changing the order of integration. So it is undouble. Now let's take this example, which will emphasize how to go or how to evaluate the volume. Here, it's not going to be a volume because you have a function inside your triple integration. So if I want to integrate this function using a triple integration, it's going to be simply, here we go, we were searching for you. Okay, here is the triple signs, and that's the integrand, which is x, y, and z. And if I want to go dx, dy, then dz, those limits or integration limits, they will run from dx, then from dy, and finally for dz. So I will integrate first on the direction of dx, which is running from 0 up to 1, and in the dy direction, which is going to run from 0 up to 2, and exactly like from dz, which is going to run from 0 up to 3. So the first thing, I will start integrating with respect to x, considering, of course, y and z as constants. So just integrating, it's going to be an x squared over 2 times yz, and then I will make the substitution, but just only on the x values, because you integrated already on x. So I will start from x equal to 0 and then 1. Then I will perform the other 2 integrations from 0 to 2, from 0 to 3. And same way like, this is going to be dy and dz. So if we make the substitution, it's going to be just only a half. Minus, replace x with 0, so all you have now is just only 1 over 2. And then I have y and z, and I'm integrating once more with respect to dy, and the integration limit is from 0 to 2, the other one is from 0 to 3, and that's for dz. Now I will integrate for dy. So if you integrate for dy, it's going to be simply y squared, okay, over another 2, which is 4, and it will be running from 0 up to 2, and the result finally will be integrated with respect to dz. So if you make a substitution, it's going to be 4 over 4, which is going to be 1, minus, if you replace y with a 0, it's going to be 0. So now we are just integrating from 0 up to 3 for a z dz. That's the z function really exists. Integrating once more with respect to z, it's going to be z squared over 2 from 0 up to 3. That's the part that we are going to substitute in. And so the final value for this triple integration, it's going to be 9 over 2. Any questions? أي مشاكل؟
سؤال
ها اتفضل.
في الزد ليه ما خليناهاش اوفر 8؟
over 8 ما هي من هنا انا هعمل هنا substitution. فانت الاول لو جيت تعمل substitution هيخلي لك الجزء ده عباره عن 4 ماينس 0 كله على كام؟ معايا جميل؟ معايا محمد؟ في دي زد؟ طبعا الاربعه مع الاربعه يديك كام؟
ماشي.
عشان كده الزد ده انه هنا وبعدين عملت الانتجريشن. ماشي؟ طبعا all of these problems you will have to resolve it using your hand. لازم ضروري جدا سهل. برغم انها سهله لكن sometimes بتبقى confusing. طيب جميل. أيوة. Once more طبعا that's our triple integration. This is the function that we are going to integrate with respect to dx, dy, dz. The integration limits already exist. Once you start evaluating step by step, by the idea, I can integrate each one of them separately. You don't have to write them the way I'm writing. You can do the inner integration, then the middle one, then the last one. So here, for example, I can integrate with respect to the x just only the x part. So x is going to be x squared over 2. If you remark, I'm just integrating this guy. Y and z are constant, which is actually what's happening. So it's going to come up to 1 over 2 times 1 yz. Now I will go to the middle integration. So the middle one, z over 2 is going to be a constant. I will integrate with respect to y. So once more, it's going to be y squared over 2. Once you start substituting, you will end up having just only z. Then I will do the last integration with respect to z, integrating z, so it's going to be z squared over 2, and start substituting by 3, you will end up having 9 over 2. So it's really up to you. I myself feel more comfortable than by integrating the integrand, then making the substitution, then going to the middle integration with the same format, making the substitution, and then the final one. But if you did it this way, it's also correct. Any questions? Okay. Okay, very good. طيب هنا بيقول in main slides you will have for this part in the main slides you have a detailed explanation of the connection between the volume and the summation notation, how it is gathered all together, and we are talking about the cubic element, which is just stratification of the volume of the surface into small cubes and adding them together through the various summation notations. You will find this on the main slides. And after gathering these summations, you will end up having the volume, the triple integration that we are handling. There is some fundamental laws and properties about triple integration. All of them are straightforward. They are exactly like the double integration. The first of them is the linearity of the triple integration, and this is really very important property because it helps you in case if you want to divide certain shape into more than part, it's going to be okay for you because it's following the linearity. So if I'm integrating AF plus BG on a triple integration, it will be the first integration, then the second integration, so it can be distributed on sum or difference. The additivity, the region D, can be split into sub-regions, D1 and D2. So instead of integrating the whole surface together, we can partition it into parts. This is the first part, that's the second one. Also, for non-negativity conditions, if f of x, y, z is greater than or equal to 0, then the region also, after the integration, you will have a function which is greater than or equal to 0. The coordinate system changes. This is really very important because in the previous, in double integration, we can make some substitutions on getting the Jacobians, as we saw in the previous lecture, and then we can make any substitution the way we like. But here you have two famous substitutions. Of course, in the double integration, we have the famous polar substitution. If you remember, I can replace x by r cosine and theta, and y can be replaced by r sine theta. And if you remember that r is running actually from 0 up to infinity, that's the limitation of r, and theta will be running from 0 up to 2 pi. Also, you know that r is the root of x squared plus y squared. This is how to move between the polar coordinates, and I've missed something. Any one of you to remember me? What did I miss here for this transformation from Cartesian to polar? Huh? The Jacobian, which states that dx dy can be changed to r dr d theta, which is the key in the double integration change. Okay? Okay. For the time being, when we are, that's for the double integration, but in the treble, we will be between cylindrical coordinates. Do you remember the cylindrical coordinates? Which is r theta and z. The r and theta will have similar relationships because r and theta are moving within the y1 or the plane of x and y. So it's almost the same. X r cosine theta, y r sine theta, z will be the same. There will be no change in the z value. And above all, the part of the Jacobian here is going to be r. So you can easily replace dx, dy, dz into r, dr, d theta, which is really very simple. In the case of spherical coordinates, we can change, if you remember the spherical coordinates, if you remember, this is the z. So I have a function, I have an angle, which is phi, connecting this member to the z-axis. So now I can replace z. The value of z is going to be r cosine phi. And for the values in the plane, it's going to be r sine phi, then times cosine theta or sine theta. So actually, in details, x is going to be r or rho sine phi cosine theta. Y is going to be the same for sine phi, but it's going to be in sine theta. But for the z, it's going to be r cosine phi, which is the angle that's opening or will be opened from the positive direction of the z-axis, if you remember. What's really matter for me, and what's new on you, is the Jacobian value. The Jacobian value here is rho square sine phi. So you will have to memorize this part carefully. So I can replace dx, dy, dz in the spherical coordinates, but with respect to r square or rho square times sine phi. And this is going to be times d rho, d theta, and d phi. Okay. Use cylindrical when I made also a comparison between the spherical and cylindrical coordinates. We'll see it in the next slide. The region is a cylinder, cone, or bounded by a circular disk in the xy plane. It will be preferable if you use cylindrical coordinates. The integrand involves expressions like x squared, y squared. The shape is revolved around the z-axis. If you have moving stuff or a revolution of certain shape and it's moving around the z-axis, it will be better to use the cylindrical coordinates. For the spherical, if the region is a sphere, a portion of a hemisphere or something, or the integrand contains a term like x squared, y squared, z squared. So it's going to be better to use spherical coordinate in this case. And this table, I've sent it to you with the slides, I believe 2 days ago or something like this. It will summarize when to use cylindrical, when to use spherical, when it's not going to make a change using either of them. So if you have cylinders, pipe shapes, it will be better to use cylindrical coordinates. If you have spheres or hemispheres, you can go with spherical coordinates. Cone or with circular bases, any one of them will do just fine. Integrand involved x squared, y squared, cylindrical will be better. If the integrand contains x squared, y squared, z squared, of course spherical will be better. Any questions? Okay, it's very, very simple. Okay, the application of triple integration, it's huge. Okay, one of them, or the first one, it is the volume evaluation, which is really very simple. All I have to do is just to integrate over the boundaries of the region, and I will be able to evaluate the volume. Of course, if I have the volume and multiply it by the mass, about the times the density, I will get the mass of a solid. So all I have to do is to get this triple integration and multiply by the density function, especially if it was given like in the coordinates that you are integrating with. It's going to be also handable. So this is the mass. If I have the mass and if I have the volume, now I can get the center of mass, which is rho dV. Then X bar is going to be 1 over m times x rho dv. Y bar will be following these rules, which is really very simple, direct substitution. If you need to evaluate the moment of inertia about the x-axis, y-axis, z-axis, is going to be really, very simple. For example, if I want to evaluate the moment of inertia about the z-axis, all I have to do is to insert x squared plus y squared in the integrand times the rho in x, y, and z rho, which is the density that we are for the material, related to the material that we are evaluating our moment of inertia around. For this part, it is the simple solid in x and y, and this slide, actually, I will give you the summary of this slide. I don't want to lose your attention. It's really very simple. If I want to evaluate a volume between two solids, we can do that. We can get the volume of U2 minus the volume of U1, or integrating from in the direction of the z from the beginning till the end of our service. So for U2 it's going to be the lower service, and U1 will be the upper service. All I have to do is to integrate in the direction of the z from U1 up to U2, exactly like we did in double integration. I will consider this is the main gate, okay, surrounding or the boundary of the volume that I want to evaluate. So I will start from U1, going into my region or into the surface that I want to evaluate the triple integration around it, till U2, as you can see. Then I will handle dx, dy the way you like it. Of course, if you make a change of variables, either in spherical or cylindrical coordinates, it will be the same. I believe this problem will be very nice to clarify and to give you an idea about the details of this work. For example, here he is asking you, consider the solid S in R cube, which consider the solid S XYZ belongs to R cube, which is x squared y squared less than or equal z. Any ideas about this shape? X squared plus y squared equal z.
Elliptic.
Paraboloid. Okay, so it's going to be a paraboloid. And it will be symmetric about the z-axis. Once we go for less than or equal z, it means it is, you are dealing with the solid by itself. And it is less than or equal to 2. يعني أقل من 2, less than or equal to 2. So we are talking about a paraboloid, okay, in the z, in the positive direction, but topped with a plane at z equal to 2. And also you have x is greater than or equal to 0, and y is greater than or equal to 0. So we actually talking about 1/8 of the space, or the first octant of the space. I believe the shape of this paraboloid, it's gonna be really very close to this. If I consider this is the y-axis, and that's the x-axis, and that the z-axis, and let's consider the walls of the part that we are dealing with, which is governed by x is greater than or equal to 0. So I'm talking about this part here, and the y is equal to or greater than 0. So these are the two sides of the plane. Okay, so we are talking about this z positive, and just only in the quarter of x positive, y positive. And for the shape of the paraboloid, you will have the paraboloid, okay, here we go, and it's like this. And if we consider z equal to 2 as a plane in here, so we are talking about this part, okay, of a paraboloid. So if you can imagine it, it's like a corner in your, this is the x-axis, that's the y-axis. Here is the paraboloid, okay? And I'm talking about just only the portion in the direction of x positive, y positive, this part only, which exists in the part of x positive and y positive. So if I want to do a triple integration simply to evaluate this guy, all I have to do is to start in the direction of the dz, which is very, very simple. And if I want to go to the solid, I will move in the direction of the positive dz, which means I am talking about this is the shape that I will face first, and that's the last. يعني لو انت طالع من اتجاه الزد هتلاقي قدامك البارابولويد اهو، ده الجيت. يبقى اذا I will integrate from x square plus y square into my region. انا دخلت جواه، ادام اطلع مين اللي هيوقفني؟ زد بيساوي 2. يبقى that's the upper gate, that's the lower gate, and that's the upper gate. This is in the direction of dz. بعدين انت عندك dx dy او dy dx, which completes the region. The main issue here is we are talking about x squared plus y squared. So changing to cylindrical coordinates, it will be a good idea. So all I have to do, if I want to change to cylindrical coordinates, which will be more helpful, that's a cylindrical coordinates. Okay, I will integrate actually from the r square, okay, x squared plus y squared into 2. So we are moving from r squared up to 2, replacing dz, dx, dy by r, dr, and d theta. For the paraboloid, it's gonna be governed by x squared, y squared equal to 2, which means in r will be moving from 0 up to √2, and the theta within the first quadrant of the plane, so it will be running from 0 up to pi over 2. يبقى انا لو بعمل انتجريشن في الدايركشن ده بتاع الار سكوير، بعدين ده دي زي الاول ده ار، وده دي زد دي ار دي سيتا، هيبقى الدايركشن بتاع الدي ار from 0 up to √2، والدايركشن بتاع سيتا from 0 up to باي اوفر 2. كده انا جبت الباوندريز كامله بتاعه الجزء اللي انا بتكلم عليه. معايا يا شباب؟ تاني، بارابولويد ده البلان زي بيساوي زي، اوكي كده؟ بارابولويد ده طالع من الجنب كده، وانا طالع في الاتجاه بتاع الريجن بتاعته. مين الجيت اللي هيدخلني جوه الجزء ده؟ الجسم بتاع البارابولويد. الجسم بتاع البارابولويد اللي هو زي يساوي اكس سكوير بلس واي سكوير اهو. انا في اتجاه الدي زد اللي هيقابلني وانا طالع كده الجزء ده اللي هو اكس سكوير بلس واي سكوير. لما بدخل جواه، لما ادخل جوه البارابولويد ده هلاقي فوقيه هو مقفول صح؟ الشكل من فوق مقفول ببلان باي اوفر 2. يبقى كأن البارابولويد طالع كده وده البلان اللي موجود فوقيه. اوكي؟ يبقى الانترنس بتاعي هيبقى الجسم بتاع البارابولويد، والاكزit من جواه هو البلان اللي بيساوي باي اوفر 2. سوري، والبلان اللي هو زد بيساوي 2. يبقى في الدايركشن بتاع الدي زد انا هشتغل من اول اكس زد ايكوال تو اكس سكوير واي سكوير اب تو زد ايكوال تو 2. كده جبت الزد دايركشن، تمام كده؟ ار يو شور؟ اوكي. طيب في الوضع ده يا ابراهيم انا بتكلم على البارابولويد ان جنرال في الزد دايركشن، بس انا مش عايز كل البلان، انا عايز قد ايه من البلان؟ ربع البلان صح؟ لان عندك اكس از جريتر ذان اور ايكوال تو 0 وواي از جريتر ذان اور ايكوال تو 0. يبقى انت بتتكلم على الجزء اللي محبوس بين اللي هنا في الحته دي. يعني اكشوال لو انا بتكلم على الاكس والواي ده البروجيكشن بتاعه عباره عن ايه؟ ربع دايره. ماشي؟ طيب الدايره دي الماكسيمم ار بتاعها بكام؟ القانون او الكيس اللي هيحصل فيها الانترسكشن هي اكس سكوير بلس واي سكوير بيساوي 2. يعني ده معناه ان الراديوس هنا ار هو بيجري من 0 لغايه √2. مش انت عارف ان اكس سكوير واي سكوير ار سكوير؟ يبقى ار ده معناه على طول ان ار بيساوي √2. طيب انا في a quarter of a circle، لذلك هتلاقي الثيتا running from 0 لغايه باي اوفر 2. يبقى ده من ثيتا بتساوي 0 الى ثيتا بتساوي باي اوفر 2. خلاص انا حسبت الدايركشن بتاع الدي زد instead of dealing with دي اكس دي واي والساينز بتوعها I will make the change of variables to cylindrical coordinates. لذلك بدل دي زد دي اكس دي واي I will replace it to r دي زي دي ار دي مين؟ دي ثيتا cylindrical. Okay, in the direction of the z بدل ما انت هتموف from x square y square يبقى انا moving from r square up to z بيساوي 2 يبقى نوت 2 يبقى ده الدايركشن بتاع الزي. طيب بالنسبه للدايركشن بتاع الدي ار خلاص انا حسبته معايا محمد من 0 روت 2 والانجل from 0 والثيتا running from 0 to باي اوفر 2. طيب تعالى نعمل انتجريشن. انا هانتجريت فيرست لمين؟ ها دي زد. لما انتجريت الدي زد ده هتديني مين؟ زد بس. يبقى انا لو انا بعمل انتجريشن هيبقى ده الانتجريشن بتاعي from 0 up to root 2 from 0 up to باي اوفر 2 integrated دي زد هيديني زي. الزد I will replace it by 2 بعدين ماينس r سكوير بعدين الفاليو اللي تطلع هضربها في r وهعمل انتجريشن دي r دي ثيتا بيساوي
ليه ضربتها في ار؟
ايه؟
ليه ضربتها في ار؟
لان ده الجاكوبيان r دي زد دي r دي ثيتا ده سلندريكال كوردينتس.
بس اول مره
طيب هشيل الزي واحط مكانه كام؟ 2 ماينس r سكوير. اصبح الانتجراند بتاعك at this time it's gonna be from 0 up to root 2 from 0 up to باي over 2 والجزء ده this part is gonna be r2 minus r square دي r دي ثيتا وبعدين ابدا اعمل انتجريشن. طبعا at this point I can integrate this guy either multiplying the r times 2 then r times r square or I can multiply by negative 2 here and then divide on negative 2. Then I can add on the power 1 on the power and divide on the new power. يعني اقدر احاول اخلي الديريفاتيف بتاع what's inside the bracket outside بعدين تقدر to integrate directly, which means we will integrate from 0 up to pi over 2. This part will be integrated. لما اعمل له integration هيدي لك 2 minus r squared to the power of 2 divided by another 2, so it will be divided by negative 4. Then I will make the substitution from root 2 and to 0. Then finally I will integrate with respect to d theta. بص شوفوا يا شباب لما احط هنا root 2 هيبقى root 2 square ب 2 2 minus 2 ب 0 يبقى الفيرست substitution is gonna be 0. For the second substitution replace r with 0, so 2 minus 0 is gonna be 2. 2 to the power of 2 is gonna be 4. 4 divided over 4 is gonna be 1. طب 1 بالنيجاتيف ولا بالبوزيتيف؟
بالنيجاتيف.
لا بالبوزيتيف.
مش بالنيجاتيف صح؟
لان انت لما بتعمل substitution بروت 2 first minus substitution بده يتكش لك النيجاتيف.
المحصله في الاخر.
اوكي. يبقى اذا دلوقتي انا بعمل integration from 0 up to pi over 2 for the function which is d theta, so simply it's gonna be theta from 0 up to pi over 2, so you will end up having pi over 2 for the value of this volume which is determined by this. This is actually the main item. Okay? شباب شفت هنا انا زي ما قلت لك انا بسرح اكتر ان انا اعمل انتجريشن الانتجريشن والمين فورم كلها موجوده قدامي. طبعا مش شرط اعمل كده. انا ممكن اكمل الدي زد لوحده واعمل سبستيتيوشن بعدين انسرتد في الميدل انتجريشن واعمل له سبستيتيوشن بعدين الفاليو اللي تطلع اروح حاططها فيهم كلهم. بس انا بفيل ماتش مور كومفورتابل ان انا امشي زي ما حضرتك شايفني كده كلهم جوه بعض. طيب خليك معايا كده نعيدها تاني.
ليه دكتور برضه في التريبل انتجريشن الجاكوبيان برضه اللي هو
هنا ار لان هو اكشن في السلندريكال هو اكنك ما هو الزد هو فانت اكنك هو زي البولر بالظبط مفيش فيه اي تغيير. بيفرق بس في السفيريكال. يعني في السفيريكال بيبقى ار سكوير ساين فاي فايل انجل اللي بتوين الزد اكسس والريديوس بتاع السفير اللي انت بتلف بيه. هنا تاني once more the volume is between the paraboloid z بيساوي x square y square and the plane اللي هو z بيساوي 2 but only in the first quadrant of the disk x square plus y square less than or equal to 2. ده الشكل بتاع البارابولويد اللي احنا بنتكلم عليه اهو، ادي x square y square. طبعا الشكل ده مش مظبوط قوي، اوكي؟ رغم انه مرسوم معانا كل حاجه بس مش مظبوط قوي. الصح بالظبط ان البارابولويد الفيرتكس دي موجوده فين؟ هنا في السنتر، وده اكس بيساوي 0 وده واي بيساوي 0، فانت اكشن بتجيب اكنك بتجيب كورتر اوف بارابولويد، معايا ربع بارابولويد.
هو مش راسمها كانها في السنتر، هو مش معلمها اصلا كوردينيت.
ما يعني بس انتوا فهمتوا قصدي، اوكي؟ وطبعا انت لو بصيت على الانترسكشن بتاع البارابولويد مع باي بيساوي 2 هيدي لك الكورتر اوف ا سيركل اللي هي الراديوس بتاعها بيساوي روت 2. ده بالفعل اللي حصل. بالنسبه لسيتي الخصماني ليه؟ يبقى اكس سكوير واي سكوير انا اشيله واحط ار سكوير. الاكس اقدر اخليها ار كوزاين سيتا، واي از ار ساين سيتا، زي از ايكوال تو زي. هعمل السبستيتيوشن اكس سكوير واي سكوير ايكوال تو ار سكوير. ده الجاكوبيان، اوعى تنسيه، ده مهم قوي مس ليلى، انه دي اكس دي زد دي اكس دي واي I can replace it with r دي ار زد دي actually r دي ار دي ثيتا and دي زد. دلوقتي اقدر تفورميوليت طبعا الليميتس زي ما انا قلت لك قبل كده، الليميتس from 0 up to باي اوفر 2 ده بالنسبه للانجل عشان الكوادرانت الكورتر بتاع السيركل. الار from 0 up to root 2، وطبعا الزي هيتحرك من R2 ل 2، من R سكوير ل 2. ليه R سكوير يا ليلى؟ لأنه أنت طالع من تحت هتقابل مين الأول؟ الباوندري اللي هو البارابولويد. بعدين إحنا جواه لغاية لما نقابل البلان اللي موجودة عند زد بيساوي كام؟ بيساوي 2، اوكي؟ طبعا خلاص أنا جاهز أهو، عملت التريبل انتجريشن بتاعي R سكوير up to 2R دي زد دي R دي ثيتا. Once you integrated dz is gonna be just only z. z replace it with 2 minus r square. يبقى على طول ده الشكل الثاني اهو. بصي انا خدت لوحده عملت الدي زد بقت بزد، عملت الريبليسمنت 2 minus r square. هاخد الفاليو دي واحطها في الميدل انتجراند. يبقى اذا الحركه اللي بعديها هينتجريت with respect to r. مين اللي ده خدته